How do elastomers stretch without breaking? Imagine stretching a rubber band and it bouncing back to its original shape every time. How does that simple stretch turn into a material that can bend and twist without snapping? Let's find out. Elastomers are a special kind of polymer, which are long chains of molecules. These chains are loosely connected, or cross-linked, allowing them to uncoil and slide past each other when stretched. Think of a bunch of spaghetti noodles that can stretch out without breaking because they are flexible and not tightly packed. One reason elastomers can stretch so far is because of reversible interactions inside their structure. These are temporary bonds like hydrogen bonds or ionic interactions that can break when stretched and then reform when the stress is released. This process lets the material extend without permanent damage, kind of like a spring that can stretch and bounce back. Another key factor is how the polymer chains distribute the stress. Instead of concentrating all the force in one tiny spot, the chains spread out the strain across a wider area. This prevents the formation of cracks or tears. When some bonds break during stretching, it's controlled and helps dissipate energy, which makes the elastomer tougher and more resistant to tearing. Some advanced elastomers even have multiple network structures inside. These networks work together to absorb energy through bond scission, which is when bonds break under stress. This controlled breaking allows the material to stretch to thousands of % of its original length without snapping. For example, some elastomers can stretch over 600 times their original length before failure. From a failure perspective, these mechanisms are what stop elastomers from cracking or tearing easily. The mobility of the polymer chains, the reversible bonds, and the way damage is spread out all work together to keep the material intact during extreme deformation. This is why elastomers are used in products like seals, flexible electronics, and soft robotics, where they need to bend, stretch, and recover repeatedly. Of course, if the strain becomes too much or if the material gets sharp cuts or fatigue over time, these internal mechanisms can be overwhelmed. That's when failure happens. Studying how elastomers stretch and resist damage helps engineers design better, more durable materials for all sorts of uses.